Looks like we were live.
I think the intro is not working, guys, so let's just go into it.
All right, cool. It's a really great intro, I think.
Yeah.
We had a great video lined up for everyone. The demo gods are against us today. We thought, how can we break this? We've automated it, but we have. Awesome. Richard, do you want to go ahead and kick it off for everyone?
Yeah, right. So welcome everyone to the first ever Azure Cloud Native User Group. I'm one of your co-founders and hosts tonight, Richard Hooper, Pixel Robots Online. I do everything AKS, Kubernetes related, Cloud Native. I want to do a special thanks to Intercept, my employer, for sponsoring tonight with the StreamYard. So yeah, over to you, Carl.
Thanks, Richard. So I'm Carl Cook. I'm, again, one of the co-founders of this new user group venture. Really looking forward to seeing where this goes. We've got an awesome guest for everybody tonight. Follow me on Twitter there. You can see it on my handle at Carl_IT_nerd. Really looking forward to seeing where this goes. So use the Azure Cloud Native hashtag on Twitter to interact with us, or just chat on whatever platform you're watching on, and looking forward to this. Robert?
Oh, sure. I was about to say April, but sure, I'll go. So yeah, hello. My name is Robert. I work for Crayon, and I'm based out of Norway. So I'm the only one that's not currently sitting in the UK, which is a great thing, because we're trying to be online and have as much as possibly online, so more people can be participating in this one. And yeah, I do a lot of things cloud native. So I work with the Cloud Native Computing Foundation. I do most of my work with Kubernetes and Terraform and stuff like that. And this is like one of the this is like a group of that I really wanted to have going, because this is the main topic for me in my day-to-day work. But there's so little out there on this topic, and we're really excited to see everyone being so excited about this. So really awesome to be here. And over to you, April.
Thank you, Robert. So my name is April Edwards. I see a lot of familiar names out there in the crowd tonight, so it's awesome to see you all comment, say hello. I'm a senior cloud developer advocate at Microsoft. I'm also the DevOps practice lead. I sit in the UK with Richard Hooper, and I can't really say in the UK with Carl, but next door to Carl, and also with Robert. So these are all three people I interact with pretty regularly. I do a lot in cloud native. I used to be on the engineering side at Microsoft, working in a cloud native team across EMEA and across the globe. Absolutely loved it. This is also a topic I'm passionate about, and I'm very excited to have everyone here tonight. And tonight, for our first guest, let's welcome in Brendan Burns. So if everyone would like to give a physical clap as we welcome Brendan in. So fun fact about Brendan Burns, he doesn't really need too much of an introduction, but he does have a boat named Orca. So that is the fun fact of the day. So thank you, Brendan, for joining us tonight from Seattle, Washington, 8 hours behind us. And thank you for everyone joining from morning, evening, etc. I'm going to hand it over to Brendan and let him take it away.
All right, cool. Can you hear me? Yes?
Yep.
All right, awesome. So yeah, I'm Brendan Burns. I'm a CVP responsible for cloud native open source at Azure. And I'm not seeing my video. I'm hoping that other people can see my video. Or yes? Maybe? We'll go for it. And I'm going to talk to you about the past and future of Kubernetes, and especially with a focus on what we're thinking about in Azure today. So you want to take my slide deck and everything? All right, cool. I see my video again too, so I'm happy now. All right, cool. And so hopefully we'll start advancing the slides and see what happens. I'm going to apologize. I can't actually see the chat in my, I have my presenter view and my slide share. So if someone has a question, feel free to just interrupt me at any time. I'm not sure I'm actually going to be able to see the questions if they pop up on the screen. Actually, I'm going to try and shrink this, and we'll see if I may be able to see the questions now if they pop up on the screen. But if I'm not responding and you think I should be, just let me know. All right, cool. I wanted to start with a history of this whole cloud native thing, I guess, at some level, because I think there's a lot of discussion about how cloud native is a new thing, and people, I mean, it's not even that new anymore, right? Because I've been at it for nigh on 8 years at this point, out in the public. But really, it dates back much, much further. And I think the origins, you can point back to people sort of starting to think about, how do we isolate processes? How do we give processes a different perspective about the way that their world looks like with something like chroot? How do we figure out how to constrain their capabilities with things like FreeBSD jails? How do we think about constraining their resource usage with Solaris zones and Linux C groups and namespaces? And so that's kind of like the infrastructure that was necessary to bring about this idea of cloud native. And then, of course, the cloud itself needed to launch too, right? You can't have cloud native infrastructure without a cloud to go along with it. So in 2010, Microsoft Azure launches. It was actually called Windows Azure back then. We're going to, it got renamed in 2014. And just before that, Docker released itself in 2013, which was, I think, a real catalyst for everybody. And in order for me to sort of give you an illustration of why it was such a catalyst for me personally, I want to start with my sort of DevOps experience, my sort of formative DevOps experience. And that was a dev, in my experience, from 2008 to 2012 as a developer and on-call for Google Web Search. And, I'd done other administration stuff before. I'd administered some Linux machines and mail servers and print servers and, basic IT-ish kinds of stuff. More because no one else was willing to do it in my lab rather than any natural aptitude. But when I went and started working on Web Search, it was a real contrast for me. Because I was very used to logging into machines via SSH, doing, running apt-get, whatever. And I expected as an on-call and a dev for something as sort of critical and focused as Google Web Search was, that there'd be no room for error. But the truth is that there was actually a ton of room for error. Like, I screwed things up constantly and nobody noticed. And the reason that nobody noticed was because of this idea of cloud native, and the way that these applications were built and developed, so that, like, literally you could take an entire data center offline accidentally, as I did once, and the world just kept on rolling. And it wasn't because nobody was visiting it. It was just because the infrastructure was flexible and dynamic enough that it could respond to something as big as, one of 18 data centers being brought offline. And along the way, I had a lot of thoughts about this thing called Borg, which was the underlying substrate that was being used for a lot of this cloud native development. And so in 2012, because of a bunch of different things, I had a personal change of focus, and it was a switch to cloud. And I don't know if everybody remembers 2012, but I certainly do, because the switch to cloud and looking at the way that people were deploying applications was really kind of a shock to the system, because I felt like suddenly I was back in that world of early 2000s infrastructure where I'd been before. And to start with, there were VMs, there were machines, there was things that were pretending to be physical infrastructure, right? Like, and that, I hadn't been thinking about that for a long time. I'd been thinking about processes. We were doing SSH again, right? And we were back to doing imperative configuration, right? And having lived it, it was, when I lived it originally, it was fine. But in 2012, when I got back in, it was a pretty terrifying world, right? It was pretty terrifying. It's the UK, so I had to give a Judge Dredd shout out. Hopefully that's appreciated. It was a pretty terrifying place to be. And what was interesting about it in 2012 was, while it was simultaneously terrifying, it was also totally unclear what the path forward was. And then this amazing thing happened in 2013, which is that Docker mainstreamed containers, right? And the reason I think it was amazing is because, like, I gave you that history lesson of all the tech that had come before, but nobody was using that tech, right? And I mean, a few people were, but not a lot of people were even aware that this technology was sort of sitting there in the kernel. And what Docker did was actually reflect both the pressures of the day, which was that everybody was starting to do cloud native development, even though they didn't know what to call it yet. That the pressures of the businesses and the pressures of the services that we are all building were forcing people into this mode of development and immutable infrastructure and all of this other stuff. Combined with a really great developer experience meant that suddenly everyone was like, oh, wow, I really see why that's so important. And it really became the foundation. I think it really became the foundation of what we call cloud native. And so what is it really that this container is? I'm not going to talk about the technical details. I'm going to talk instead, I think, about the motivations, because I think they really underlie what it means to be a cloud native. And I think the most important thing is it's a place to hold all your stuff, right? Like, we need structure, we need boxes. I mean, I'm in my basement right now, and I think about, if I didn't have bins in which to put stuff, I wouldn't know how to organize anything, right? Before you can even start thinking about how to organize, you have to have the things that sort of provide the structure for the organization. And I think that's the first thing that the container really did for everybody, as well as a reason to go around organizing your things, right? Before, the virtual machine, it looked much like my basement, stuff scattered everywhere, wherever I happened to have set it up or worked most recently. And the container, by providing that structure, by providing that sort of bin in which to put things, gave you a reason to organize things together. And more importantly, and I think this is an important part of what it means to be cloud native, it meant we're going to actually organize things much like we organize classes. We're going to organize things around the people who built them, right? And we're going to organize things around the notion that software is continuously being deployed out into these environments, and keeping it separate, enabling it to be agile, is a key characteristic of what we needed to do. But it's more than just about organizing and packaging your stuff together. It also became a distribution mechanism, so that I could very easily, it's I don't know how many people remember, or maybe some people out there still are, but like, deploying your software around the world used to be a problem that you had to solve, right? It's no longer a problem that you need to solve. And that's a really great thing. And I think that's something, it'll be a theme for sort of some later parts of this talk, which is to say, we need to do more of this, like identifying and building infrastructure that solves a problem permanently and nobody ever thinks about it again, right? We have too few abstractions in the cloud right now in order to really be effective. And I think this is a great example of how if you build the right piece of software that's oriented around the ways in which people are deploying into the cloud, you take a problem that thousands or tens of thousands of people are individually solving, you give them one good solution, and they immediately forget about anything else that they possibly wanted to do, because they didn't really care. They just wanted this thing to work, right? And then there's also a bunch of effort that went into runtime isolation. This is valuable more because you want to be able to sort of multi-tenant things together on the same machine, not steal CPU from each other, be able to deploy an intern's application next to your production application and not have user impact. This is sort of a later concern, not a concern that really drove a lot of the early adoption. But as we went into this cloud native revolution, what we noticed was that Docker is only focused on the machine, right? They'd only built a piece of the solution. This is the Space Needle under construction, by the way. I don't know how many people have been to Seattle, but this is an iconic thing in Seattle, and this is what it looked like halfway done. And I feel like that's what we felt like with Docker, was that like they'd started this revolution, they'd started this amazing thing, but they'd only built it halfway. And so we started thinking about, how do we think about what the pieces are that we need to be putting together. And, I think when we were thinking about what are all these pieces that we needed to be putting together, we were thinking about things like, hey, replication has to be super, super easy, right? We need to make sure that running n copies of something is the same as running one copy of something. We want to be able to decouple all the things, right? We want all of the different pieces. If you're thinking about cloud native development, and again, it means the ability for independent teams to behave independently. We need infrastructure to support the decoupling of services with service load balancers in between, the decoupling of a deployment of software from the replicas of that software, and also namespaces to isolate different pieces of the software. We need this decoupling to happen. There's also some minimal viable tools that we had to build. like naming and discovery, that was really a critical piece. Like previously, there is no name. You can't just sort of be like, I want to talk to my database. You said, I want to talk to, 10.14.16.20, right? Some IP address. And if you were lucky, you said, I want to talk to some DNS address. But it wasn't dynamic, and it didn't sort of, if you scaled out, you had to adjust things. This is a core capability of what it means to be moving in one of these spaces where applications come and go, and you still need to be able to find your way through that, the sea where, the thing that it means to be the database may have actually changed its location from one machine to another, one IP address to another over the course of its lifetime. And you still need to be able to connect to it. I think one of the most interesting things that happened along that journey that is still having repercussions today is that there was no hierarchy. This was actually something that is still sort of percolating through the cloud native space. We said we're going to have labels and we're going to not have hierarchical relationships, but we are going to have namespaces, which is like a sort of limited form of hierarchy. And more recently in the Kubernetes community, they're starting to talk about nested namespaces, which is sort of reintroducing some of the hierarchy. And it's very interesting. And actually in Azure, we're having the same discussion because Azure has a degree of hierarchy with resource groups and things like that. But we're finding the limitations of that hierarchy and pushing more towards being able to do things with tags. I think this is just, I don't know, it's probably very dorky of me, but this is one of those topics that is endlessly fascinating to me, because it just keeps popping up in all of these different environments where the simple thing is to have everything in neat little folders. But the thing that is actually flexible enough to embody the real world tends to be tags and labels and a total sort of absence of hierarchy. And that push and pull, it's one of those things that has sort of been around for my entire career in a semi-unresolved state. And so it's just an interesting, I don't know, I could probably go on for a long time about that, but it's an interesting problem. And then the final thing that we were thinking about is that this thing has to be born in the cloud, right? It has to be thinking about APIs and API-driven applications, no matter, even if it is running on physical infrastructure, it has to feel like it's running in the cloud, and it is going to have expectations that it's running in the cloud, as well as it has to be open source, because of course, this is a key component of, I think, what it means to be cloud software and what it means to be cloud native, to be honest, is this amazing realization. And I've been around open source for a long time. And open source kind of went from like a fringe movement to an alternative movement to now, I think, a ubiquitous movement. And, along the way, things like GitHub got purchased by Microsoft, and is arguably, one of the two crown jewel social networks for work that exist in the world, right? And it's funny to think of a source control system as a social network, but it is. And it's funny to think of GitHub as Instagram, but for a lot of people, it is Instagram. And so open source is an essential component of what it means to be cloud native, because frankly, the people who are deploying to the cloud expect that they're going to be able to introspect their source code. They're going to expect that they're going to be able to collaborate. And I think, as I'll point out later on, the problems that we're trying to solve are simply too hard for us to go it alone. We have to figure out ways to come together as a broad community across competitor relationships, across industries. And frankly, the only way that people have figured out how to do that is open source. I wanted to take a brief aside. Probably everybody's heard this now, but there's the story behind the name, which is it was originally called 7 of 9. That was what I called it when we started it. It was a joke. I'm a Star Trek person. Well, I'm a sci-fi person in general, actually. But I was thinking about Star Trek. That name didn't make it through trademark. We had another name, which was Project 7, which also didn't make it through trademark. I was really sad about that because I loved the notion of like, well, what happened to the other 6 projects? Like, why are you on the 7th one? And of course, we had no idea. Like, Kubernetes meant nothing to us when we started throwing names around. And so, so many years later, for us to have this thing become such an important word around the world is really kind of an amazing journey that we've been on. Honestly, something that I've personally sort of been able to take a lot of pleasure from, seeing people find my software useful, find our ideas useful, but also really a ton of gratitude for the broad community that came together or rallied around this thing to create it. So that's sort of, in a whirlwind nutshell, 20-minute, 15-minute tour of the past of the development of cloud native. I'm going to jump forward into the present, right? Which is that Kubernetes is now a commodity, right? You can now go onto every public cloud, Azure included, and get Kubernetes. And many times people come to me and they say, tell me, I'm in these customer meetings and they say, tell me how your cloud is differentiated. How is Kubernetes on Azure differentiated from the rest of the world's Kubernetes? And I look at them and they say, what you're asking me is kind of like asking me how my x86 is differentiated, right? I don't actually think you want this thing to be differentiated. You're looking for an open API. You're looking for a commodity. And so what's important for me to talk to you about is not how I deliver this service on top of Azure, but how I build upon, what's coming next to start from this foundation and deliver new things on top, right? And so I think for the remainder of this talk, what I want to talk about is what we're building on top and what we're pursuing as the way of actually differentiating, because this Kubernetes layer is a commodity at this point. I wanted to start with a somewhat controversial statement, certainly controversial amongst some of my peers who may run some of these services, but that's that PaaS is dead, right? And what I mean by that is that for a long time, the world was divided into two camps, if you will. There was IaaS on one side, and you just got infrastructure, and it was x86 as a service and physical analogs or virtual analogs of physical things. And then there was PaaS, platform as a service, purpose-built top to bottom to deliver web or to deliver functions as a service or to deliver database as a service or whatever it happens to be, right? Very vertical, really targeted around specific use cases. And there's tons of different versions of PaaS that exist. Ironically, Docker itself started as a PaaS provider called .cloud. And Docker was built as a foundational component for what it took to build a PaaS. And I think that this is the interesting point, which is that as I say PaaS is dead, I actually am also going to say long live PaaS. Because what has happened and is happening and is the future of where we're going, both on Azure and I think in the industry broadly, is that PaaS is actually just being reformatted and recirculated into what actually I think can be the foundation for the future of development of cloud native technologies for the world. So when we think about PaaS, what is it really? Well, PaaS involves packaging. How do I get my application somewhere? Whether it's, hey, let me upload a function let me write a function. Then the uploading part, that's deployment, right? How do I actually take the code from running on my laptop to running out in the cloud? And then there's reliability. Keep my code running. If it crashes, restart it. If it needs to be scaled out, scale it out, right? What's interesting is if you look back at that past history and of the progression of Kubernetes across the timeline, three of those are taken care of by containers in Kubernetes. Once you combine a container image registry, a tool like Kubernetes for deployment and for automatic restarting and auto scaling, you've taken out three of the four things that define platform as a service, right? And so what is left? Well, what is left is developer experience, right? Which was arguably the most important thing and the thing that the PaaS was the most interested in anyway. So that's great, actually, because it means that we've effectively taken on the undifferentiated heavy lifting and we've enabled people to focus on the thing that they cared about, which was the developer experience, the thing that differentiated them, which was the focus on a particular vertical. And so, of course, we have seen in the history of Kubernetes the development of a myriad of serverless functions as a service on top of Kubernetes, right? Including Azure Functions, which you can take and you can run Azure Functions by itself, open source on top of Kubernetes, right? What does it say that, I mean, last time I counted, it was something like 19 different implementations of functions as a service on top of Kubernetes. What does that say? Well, that says a couple of really interesting things. One is that the developer experience for Kubernetes is insufficient, right? If everybody loved developing applications on top of the raw Kubernetes APIs, nobody would bother to build these functions as a service implementations because there would be no point. But of course, it is actually complex to build, package, and deploy your application as a container. And so these environments make it much easier to do so. But the fact that there's 19 of them, and there are not 19 cloud-based functions as a service that I know of anyway, means it's actually very easy to create one for Kubernetes also. And I think those two things are really critical for everybody to keep in mind as we think about the future of where we're going. The developer experience needs to be better. It's very easy to build developer experiences. But also because of all of the componentry that's being supplied by the underlying API, what we're looking at now is not a monolithic choice of, I'm going to choose to do things in functions as a service, or I'm going to choose to do things in Heroku style web paths. What we're seeing actually is that every single PaaS that exists is getting refactored and rebuilt and reoriented to these Kubernetes APIs. And when you look at things like the announcements around Azure App Services being, ported to Kubernetes and running out in Azure Arc on the edge, or if you look at Azure Container Apps, which is a recently launched service from Azure that is entirely built from the ground up, starting with the Kubernetes API, even in Azure, even when you use it and you don't even know that the Kubernetes API is there, it's underneath what you're doing. Shows that this is the future of the way that platforms are going to get built. This is the foundation for every single thing that comes after it. And partially it's all that undifferentiated heavy lifting that I mentioned before. But partially it's also the fact that one of the Achilles heels of platform as a service always has been interoperation. How do I get that Cloud Foundry application to talk to a functions as a service application, to talk to an app service, to talk to a raw container, to talk to a VM? Interoperating services across these different environments within the cloud has historically been extremely challenging. And it's because they were each their own little walled vertical garden that didn't have any kind of shared infrastructure. But with Kubernetes, you have shared networking, you have shared image formats, you have shared naming and discovery, you have shared, basically everything except for the experience is shared, which makes interoperation tremendously easier. And of course, because of that, means that over the lifespan of your application, you no longer have to, radically refactor it when you need to maybe switch from functions as a service to a raw container or anything else. And of course, it's not just about it's not just about like what user-facing developer experiences. Big data is being ported over here too, right? And so suddenly I think we're really getting to a place where the choices that we make about how we build our applications can be based on a collection of technologies, with each piece of technology serving the purpose that it was intended for, but also interoperating in a way that previously had been very, very complicated to get right. And of course, the final piece of this is that, it's not just about consuming these platform layers. It's actually about people starting to build platform layers, right? It's about people starting to say, hey, actually, if this thing's not that hard, why don't I start building a platform layer for my company? Why don't I start thinking about building a platform layer for the kinds of applications that I want to build, right? And I think this is also representative of the sort of creative explosion that we're seeing in the ecosystem right now, which is very similar in many respects to the explosion in sort of the app ecosystem that we saw with the development of the first smartphones, the very sort of explosion of desktop applications that we saw when something like Windows was introduced in the mid 80s. I think anytime a platform makes it radically easier to build something than it was before, you see this explosion of different applications popping up to serve different interests because just people feel like it. And that's really, really great for us to do. But the thing about this is that we've gone forward and we've created the ability to create advanced technology, but we've also created a bunch of complexity, right? And if you think about, this is my example of like over engineering. I mean, it's an awesome achievement that they can land 2 rockets using their engines at the same time on the same place, but like a parachute would have been easier, right? And there's reasons for that, and you talk to Elon Musk if you care, but like sometimes as engineers we build complexity just because we love complexity. And so I want to sort of say like, hey, as we think about this world where we suddenly can build more things, what are we really trying to do? And what we're really trying to do, in my opinion, is to democratize distributed systems, right? And so along the way towards building these paths, I want us to be really, really focused on, you know, are we enabling more developers to be more successful in the cloud, right? Are we enabling people to do less? Are we teaching them fewer things? Are we automating common tasks? Are we enabling standardization on implementations? And not just build, you know, not just sort of build a, don't force people to reinvent the wheel every single time they sit down to write an application. And I think this is a place where Azure and Microsoft really have a lot of pretty special DNA. I think we've spent I mean, it's in our mission statement that our job is to empower the world's population to do more. But that sense of using technology to empower people is just a part of Microsoft's core DNA from the beginning, in my opinion. And so I'm hopeful that as we move forward in what we're doing, that we're going to, you know, actually deliver on this thing. I wanted to talk about, I'm trying to figure out if I should skip forward or if I should, I think I might actually skip forward just in the interest of time and having questions to what we're actually sort of doing here, right? So here is this sort of idealized picture of what the world looks like now, right? Kubernetes is ubiquitous, it runs on any infrastructure, the world has been simplified, you're ready to go. But in fact, actually, in this cloud native world that we live in, it looks like this. This is, someone mentioned going to KubeCon earlier in the conversation. This is the CNCF roadmap, so whatever project map thingy that they developed. This one's actually probably even out of date. I think some things have been added since then. It's a total eye chart, in case you hadn't noticed. And the net result is we've got a lot of developers who are sitting there being like, I don't know how to do this. And more recently, not only are a bunch of developers sitting there thinking, I don't know how to do this, but they're not sure how to secure it either, right? And this is a really important point, I think, because it's great that we talk a lot about agility and it's great that we talk a lot about pushing software. But I think that one of the things that we don't really talk a lot about when we say cloud native is we don't really say under attack, right? And to be cloud native is actually to be under attack. You know, it's really to be out there on the public internet in a place where we are exposed to users and where, unfortunately, people in the world are attempting to break our systems, right? And so I think while we as developers like to focus a lot of our time on what it means to build things quickly and, you know, release and iterate, I hope that we are also simultaneously thinking about what it takes to build these systems securely. And, you know, that's actually really, that's the wrong thing. That's actually really a major focus of what we think about when we think about how we approach things within Azure. And I think that the truth of the matter is that these things can actually come together and actually really, in order for us to do a really good job, should come together. And to do that, I wanted to illustrate something that we've built recently in VS Code. Did I just turn on trend? I turned on subtitles. I'm going to turn that back off. I didn't mean to do that, although it's cool. So one of the places where I think we can really illustrate the ways in which developer productivity and security comes together is VS Code. And I think it also really highlights, the sort of massive collection of DNA that we have within Microsoft that really does think about everything from an end-to-end perspective, all the way from the place where you do your software development, the source repo where you store that software, all the way through to the place where you deploy it. But what I wanted to focus on right here that I have the little arrow pointed at is this little tool called port forwarding. What you see here is the Kubernetes extension for VS Code. If you haven't installed it, please go and install it. Much like Kubernetes, I wrote 80% of the original, and much like Kubernetes, 80% of what I wrote has been replaced. But it really does a nice job, I think, of integrating a Kubernetes cluster into a familiar development experience, gives you a nice tree view of your stuff, but more importantly, gives you things like a context menu, right? So since the dawn of time, when you right-click on something, you've been told you'll get interesting stuff that you can do to it. And when you right-click on a container in this view, you can see that you can securely port forward. The thing about this is that if you don't enable developers to have easy access to tools like this, if you don't enable them to quickly discover tools like this, they'll do they'll take the fastest path to something that works. They'll take their container, they'll put it out on the public internet, and the next thing you know, you're going to be in the headlines like this, right? And so I think this is a great illustration of effectively how, when we think about security and when we think about cloud native development, we have to be thinking about those two things hand in hand. We have to make sure that the practices that are necessary for the developers to build things quickly and to release things quickly provide them with a happy path that also enables them to develop securely. And I think, I like the VS Code introduction as a way of sort of shaping our philosophy when it comes to developing things for the cloud native ecosystem and the tools that we bring to bear from Microsoft and Azure. And of course, this extension is built despite the fact that we built it. It targets Kubernetes anywhere, because that's another important part of this. To further illustrate sort of how we think about open source and securing things, I wanted to start out with a little aside to access control. I think we're all familiar with access control. It basically says good guys can do things, bad people can't. But it's not sufficient. And when we looked at this, especially early on in the cloud native ecosystem, it's interesting to think actually, Kubernetes actually didn't have role-based access control when it was first created. And I don't remember exactly what release it came in, 1.3, 1.4, or something like that. We were like, oh man, we're enterprise now, we're adding role-based access control. But it does now have role-based access control, and it's a good thing that it does. But it's insufficient, right? And we had a lot of people who are asking questions like, where is that image coming from? Or did you get a security review? Or even more mundane questions like, who's running this service, right? There's a bunch of metadata that you need in order to build good automation that is missing, and it is not something that is required to be provided that RBAC can't help you with, right? And so when we looked at this problem in the cloud native ecosystem, we said, all right, we know how to solve this. We've solved this in Azure before. We've used Azure policy to go and be able to introspect down into the objects themselves and say, okay, great. RBAC says you can create a pod. Policy says this is what a pod should look like, right? And along that way, we created this project called Gatekeeper to ensure that you can have compliance. You can ensure that images can only come from your private registry, or that anything that's creating a public IP address has to have gone through a security review, or that if there's metadata that points to a service owner, like an email address, it has to be attached to an application before you deploy it into the cluster. And I think that this, I think sometimes people think when they think about cloud native, like, oh, this policy is heavy, and like, why are you doing these sorts of things? And I would come back to the fact that ultimately, at the end of the day, when we think about cloud native development, it's not just about building a really, really fast sports car so that you can be as agile and as fast and as shiny as you want. It's also about putting guardrails along the highway so that when you're hauling down the highway in that fancy sports car, you don't go flying off a cliff and crash and burn, right? And so I think sometimes in what we do, we focus a lot on the go fast parts and not so much on the guardrails parts. Obviously, as I was mentioning earlier, the the nature of what it means to be cloud native is to be out in the open source. We helped create this, Azure helped create this project a while ago, donated it to the CNCF, and now it's pretty broadly accepted as, you know, the implementation of policy for Kubernetes, not just by us, but by other providers as well. And I think that's, again, a real strong illustration of how, you know, Azure has had the ability to not just consume this technology, because I think for a long time, and frankly, when you look at some of our competitors, they just consume open source. They don't actually participate. They don't actually create new things. I think it's a great illustration that we really do within the Azure family at this point, within the Microsoft community. And I mean that broadly, not just the people who work for Microsoft, but all of you and the people who are participating in all these forums. We have the ability to create new projects. We have the ability to look out into the cloud native landscape and say, you know what? Our experience shows that there's a hole here. Let's go build something on GitHub together. And whether it's Gatekeeper like this or Kata, which I didn't mention, but came out of the functions team, we really can see really amazing collaborations between you know, people who are working on building Azure products, people who are using Azure products, and frankly, our customers who are using Azure as well. I wanted to show another example of sort of some of this collaboration that we see, and that's around scaling DevOps. So one of the things that we noticed, and many of you probably have noticed, is that the minute you have more than a few clusters, managing all of that becomes quite hard. And so lately, we've been really excited about helping advance the state of GitOps. You know, when you think about GitOps, basically, it's the combination of a Git repository and a way of synchronizing that Git repository to the cloud so that you can have a single source of truth. I think this story is a great one for Azure and Cloud Native, because in this particular case, we didn't create a new project. In fact, we just went out there and we said, hey, there's this other existing project called Flux. And we really we think it's the right choice. We're going to go use it. But we're not just going to use it. We're actually going to give back, and we're going to get involved in the people who are thinking about not just, you know, how to bring this into Azure, but actually the broader community that was being developed, that is being developed around GitOps. I really think that this represents the future of how we're going to manage not just our systems that our customers are using, but actually, honestly, we're looking to see how we can use this to manage our own applications as well, because the pattern is a strong one. And again, all happening out there in the open source community, and in this particular case, in collaboration with Weaveworks and others who helped create the Flux project in the first place. The final thing that I want to talk about, because I don't want you to think that I'm just focused entirely on ops and that, you know, our innovation only comes from securing things. Let's see a question. Why was the choice made for Flux and not Argo CD? Well, at the time, there was I'm trying to find my presenter mode again. At the time, actually, if I remember correctly, the chronology, I'm not 100% certain on the chronology, but if I remember correctly, at the time, they were on a path to merging. And that path to merging actually kind of fell apart, if I remember correctly. And so, I mean, I think it's fairly arbitrary. I guess I think we have good relationships with the folks at Weaveworks and others, and so it was a natural place for us to fall into. I don't want to say that, like, I'm not sure that I could say, hey, you know, Flux is 10 times better than Argo CD or anything else like that. And if people want, you kind of have to choose one, I guess, if you're going to focus on it and put it into your product. But obviously, one of the things we do when we focus on things and we bring them into the product, we don't make it an exclusive choice, right? So if people would rather use Argo, they don't have to turn on Flux. They can install Argo themselves and use that. So that's my, I'm afraid I don't have like the perfect answer that's like, it's these three capabilities and this is why we chose it. But that was the way that it happened. All right, cool. I wanted to talk a little bit about what we're doing with developer and developer productivity as a way of closing. I don't know how many of you had a chance to look at Dapper. It's our standard library for Kubernetes, or at least an attempt at a standard library for Kubernetes. You know, and really what this is starting to try and talk about is how do we provide that shared infrastructure, shared code, so that people can do things and focus on their applications and not on the details. What's been interesting about Dapper since we've started it is that it turns out that actually it's not just useful for sharing implementations. It's actually extremely useful for dependency management, right? So one of the things that we've seen with an increased focus on software supply chain and software bill of materials is that managing your dependencies suddenly becomes a very, very important thing that you can do. And a very important part of staying secure is actually reducing the surface area of dependencies that you depend on. And we have seen people really see that if they can depend heavily on Dapper, and then Dapper takes responsibility, and the Dapper project takes responsibility for finding and vetting and including the right set of dependencies, that's actually another piece of undifferentiated heavy lifting that's been taken away from their developers. And it becomes a really meaningful way in which they can get a handle on their sort of software dependency lifecycle and software bill of materials. So that was something we weren't thinking about. I think every once in a while there are these things you're not thinking about when you create a project. It's not something we were thinking about when we created Dapper, but it is something that has resonated with people as we've gone forward. So if you look at Dapper, this is what it takes to store something into a key value store in Dapper. This is all the code that a customer needs to write, or a user, not a customer, but a user needs to write. You'll notice that it's missing a lot of stuff that you would otherwise think. It's missing that client library, as I mentioned before. So you want to store something in Cosmos, you don't have to figure out which Cosmos, you don't have to figure out which, variety of Cosmos to talk to. You don't have to include a library. You don't have to make sure it's up to date. All you do is do an HTTP post. And every single programming language that exists at this point knows how to do an HTTP post. There's no encryption. There's no authentication. It's just talking to localhost. And that isn't because this is some sort of demo, practice application. This is because that Dapper co-process that's sitting there alongside your container is taking care of all of those things for you. It's taking care of encryption. It's taking care of authentication. It's taking care of having the client library inside of it. This is also really nice because, as I mentioned about going from cloud to edge, it means your code becomes portable as well. And then I think what's also really exciting about Dapper is that we're integrating it in other parts of Azure as well. So it's inside of Azure Container Apps. It's going to be present in Azure Functions. And I think this is really important also because one of the things that I feel like we really missed when we started building this cloud is the notion that programming for the cloud should be consistent, right? We've allowed every single different environment, whether it's a VM or a container or a function, to kind of have its own special flavor of what development looks like. And it's good for innovation, but it's really terrible for end users, right? Because suddenly things you learned if you built an Azure function, they don't work if you're in a legacy J2EE or ASP.NET application. And in fact, Dapper does, right? So Dapper actually can work in a functions environment, but it can work alongside an existing legacy application as well, right? And it doesn't try and take over. If you have connections that are going to some legacy database, those connections can persist. You can gradually shift connections to using the Dapper sidecar. This kind of incremental adoptability, I think, is huge and is really part of the reason why way back when Docker became so popular as well. It was very incrementally adoptable. You could start using the same bash scripts that you would ever use to create a Docker container instead of installing imperatively on a virtual machine. You could start deploying Docker containers, and it looked a lot like running something under systemd. And you didn't jump from like source code to orchestration in one jump. There's a bunch of iterations that happen along the way for people to get there. And I think that's a key aspect. Whenever we build these technologies, we have this real desire to like build the beautiful, perfect new thing, but not think about how people get there. Not think about what the journey is and the voyage is. I'm guilty of this too, right? I've done this before as well. But we have to be focused on the journey of how people get from where they are to where we want them to be. Because if we don't, like, we build beautiful crystal castles, but like we leave a bunch of people behind in, horrible apartment buildings from the Bauhaus era or whatever. Is Dapper the SDK of multi-cloud? Well, I certainly hope that's one of its characteristics. I hope it's not just focused. I hope that it's not just about multi-cloud. I hope that it is also about sharing implementations and building an ecosystem of patterns that people can use and not have to re-implement every single time. So it's not just about multi-cloud, it's hopefully also about shared implementations and broader patterns. But definitely portability is one of the things that we were thinking about, because it is a problem, especially as you think about not just multi-cloud, but going from cloud to edge. That's also a problem as well, right? Like all those fancy cloud services that you were using in a hyperscale public cloud, they disappear when you're on a factory floor. It may be obvious from this illustration, but Dapper is polyglot. It can be accessed from any language that speaks HTTP or gRPC. And it has a bunch of different components. I don't want you to take away thinking that, oh, it's just about storage, right? It actually has similar components for secrets. I think some of the eventing mechanisms are even the coolest, because we've gotten very used to, like, if you live in a functions as a service environment, receiving events is really, really easy. But if you're a legacy application, good luck. Dapper can actually make it just as easy for you to receive an event in a legacy application as it is for you to receive an event in functions as a service. And I think this is really, really important, because I think event-driven architectures, more so than serverless or containers or orchestration or anything else like that, I think a shift towards event-driven architectures is going to help us achieve some of that democratized distributed system goals that we aspired to at the beginning. And I think that that's because if you look at sort of application development, the same kind of transition from writing a complete program to actually just sort of writing a program that responds to events represented a significant, I think, step forward in the ability of people to write desktop applications. Right? When you had to very carefully listen for keyboard events and listen for mouse events and figure out where on the screen something was clicked and all that sort of thing, it was much, much harder to write a really good desktop application. I think the minute people came along and said, no, actually, we'll take care of all that for you. When someone clicks on your button, we will just fire you an event that says button clicked, represented a real democratization of desktop applications. And I think that a similar kind of shift, hopefully, will empower people to build more distributed applications as well. I see another question coming in. The big functionality gaps in Dapper to be aware of right now. I would never say feature complete, because I think that we always hope that it will continue to evolve, but it's hit a 1.0. And so for the things that I listed here in terms of storage and secrets and events, authentication, actor patterns, it's production ready and ready to go. And so definitely encourage you to check it out. And what's more important about it is that it's completely incrementally adoptable, which means that if you want to use the storage bits but not the events bits, fine. You want to use the events bits but not the storage bits, fine. You want to use just authentication middleware, fine. Right? And so I think that's also really, really important, because it means that if there are pieces that aren't well suited to your needs today, but there are some that are, you don't have to, you're not forced to use a bad implementation just to get access to the piece that you want. Right. And so I think that sort of modularity is another really key aspect of a well-designed system, and definitely something that we're focused on with Dapper. I wanted to end the talk with just a call to join us. You know, and I mean, this one's focused on Dapper, but actually more broadly, much of what I just talked about, whether it's Gatekeeper, Dapper, Flux, these are all projects that are out there on GitHub. All of AKS is frankly out there. You know, the issue trackers and roadmaps for Azure through the Azure Kubernetes service is out there on GitHub. You know, I really, really view this as a journey that we're all taking together. And I know for a fact that a lot of this stuff is only going to be successful if we build it together. And frankly, if you can advocate for me when I'm not in the room. And so please come and join us, whether it's with Dapper or anything else. I think lots and lots of people know how to reach me on Twitter and everywhere otherwise. But please don't hesitate to contact me at any time. And looking very much forward to seeing how Cloud Native goes forward with this user group and Azure and even beyond. So thanks so much for the opportunity to kick it off. And now I have about 5 minutes, I think, for questions. So thanks, folks.
Awesome. Thanks very much for that. We do have a nice long question. I'm just going to bring it up on the screen. I'm just got to find it in the big long string of messages. This one here. Just add April in as well. So yeah, it's a long one.
Actually, had mine from there's a retweet, but yeah, I can just read it. It's Susan from LinkedIn. He said that the ecosystem of Kubernetes seems to be constantly evolving. Will there be a point where the tech will reach some level of stability? Currently, DevOps and others need to be aware of the gazillion different components, everything from Helm to Argo CD, etc. It would be nice for some sort of standardization. And I have a lot of opinions on this, but feel free to just.
Yeah, I mean, there's a part of this which is just the cathedral versus the bazaar, right? Like, the cathedral versus the bazaar has been a component of open source from the get-go, right? Like, and it's a necessary component of open source, which is if you want to facilitate open collaboration and you want to facilitate people feeling empowered to build new things, you're going to have to tolerate a bunch of choices, right? Now that said, I think that we do need to get much, much better at, both as a community, not building things just because we want to have built it, but rather joining things that look like what we want to build. I think sometimes and I don't want to discourage people necessarily, but at the same time, there's a time when it's useful to have, sort of more wood behind fewer arrows rather than a few arrows. And I think that's just an evolution that we have to go through. I think that, as a cloud provider, we try and do some of this as well. And we're trying to do more and more kind of giving people not just raw ingredients, but maybe maybe the best way to say this is you can always buy whatever Lego bricks you want, but they do also sell you Lego kits. And the chances are that if you want to build something complicated and pretty, you should buy the kit. Right. And I think we are trying to do a better job sort of figuring out here's the web serving kit of parts. Here's the, and when you're building it, I think, and just to carry my Lego analogy to the end, when you're building it, you rarely second guess their choices. You rarely are like, oh, well, this piece, I wouldn't have used that piece. I would have used this piece. Because at some level, you don't care. You just want the end result. Right. And I think that we're trying to kind of come up with that set of parts. I think there will be stabilization. I think you already see stabilization in the sense that there were a ton of orchestrators once upon a time. There's not now. There's one orchestrator. There was a lot of container runtime choices with Rocket and that sort of thing. And there are, in theory, multiple container runtimes, but I think most everybody who's not running a Red Hat distribution anyway is running Containerd. And I think there are these places where they seemed really, really important. They seemed like there was a ton of passion around the orchestration wars, and there was a ton of passion around the container runtime wars. And, that passion is cooled a lot. People don't really care anymore. They've moved on. There are new problems to solve. And I think over time that's going to keep happening. And as people stop being really excited about a particular layer, it tends to quiet down and sort of the best solution tends to win. But even today, if you look at the Linux ecosystem, there's a bunch of different choices. Obviously, some of them are a lot more popular than others, but flexibility and choice has always kind of been a hallmark of open source. So I don't know. It's a hard topic for me to because I really do want to provide opinions, but I also don't want to box people in.
And you kind of get into what do you mean by stability? Me as a person that's using Terraform has been stable before it had the 1.0 release. It's been stable. So, what does that mean? And I think, especially the cloud native ecosystem had a lot of moving parts. And it's if you want to do something, or there's 600 choices at some point because everyone was just doing it. But it's slowly getting to a point where we have a lot of standards. We have a storage standard. We have, a service mesh standard. We have we have all these standards, and more you have tools that have different small, particular points. They have this little feature extra here that you might need and over here, but they're using the same standards. So I think we are kind of at the point where things are pretty stable. It's not like Kubernetes is going to go and do an entire new thing all of a sudden. It's continuing to grow what it already has.
That's for sure. And I think the foundational layer is definitely set, right? I don't think Kubernetes has added anything particular. I guess IPv6 is sort of a big addition, but not really. If that's the biggest thing that I can think of in the last couple of years, that's not really that big.
Yeah.
There is a new thing, and we actually have a question on, is with AKS, we've got the new node pool types, so the WASI WASM ones, and that's quite big in my opinion. Any thoughts on that?
I mean, I'm really interested in this area. This is one of these ones where I'm like, I have no idea, right? Like, it looks like the right thing at some level, but it's so early, right? I mean, I don't know how many people have actually tried to build like a WASM program, but like, it's pretty painful, to be honest. The developer experience is not that great, especially if you stray very far from like Rust. If you do it in Rust, it's relatively straightforward. If you do it in JavaScript, it's relatively straightforward. So like there's a ton of work, like just bare bones usability work that is necessary there. On the other hand, if you think, hey, I really need to write portable code that could conceivably go from a cloud system all the way down to a microcontroller or out to a web browser or a mobile device, like it's hard for me to come up with a system that would be better. And so I sort of look at it and go, yeah, it probably has all the right characteristics. And the WASI standard in particular is like relatively under-spec'd. I think it's really interesting though, because I think that it represents an opportunity. I mean, I said this in a different context, but you know, the container, the downward side of the container, the upward side of the container is very cloud native. The Kubernetes bits and the like, all the deployments and all that kind of stuff, that the stuff that the container faces up into is very cloud native. When you look at what the container faces down into, it's an I mean, Linux at its core is an operating system that's based off of concepts from the 1970s or before, right? Not cloud native at all, right? Very single machine focused, very like not cloud native, right? And so the other interesting thing I think about WebAssembly is this idea that maybe we can use this runtime as a way to explore what does it look like to build a cloud native container? Because the container itself is not cloud native. The usage of containers is very cloud native, but the container itself, in terms of the way that it interfaces with the operating system, very not cloud native. And I think some combination of like WASI, WASM, and Dapper, where Dapper is trying to provide some of these like hooks of like, hey, event handling. Like, why isn't there a syscall for event handling? I mean, clearly the Linux kernel is never going to, deliver JSON events into your container as a syscall. But if you're writing cloud native applications, like shouldn't that be a syscall? Isn't that kind of a syscall? Right. And so I think there's this opportunity with the constellation of those three pieces of technology to do something really, really interesting. Whether it happens or not, I mean, very hard to say. These things are like catching lightning in a bottle.
Good point. So do you have time for one more question? Or...
Sure.
Yeah, I just find that it's about function apps. This one here.
I don't think Azure Functions are dead. I definitely want to be clear about the fact that I said PaaS is dead as a way of starting a conversation, not as something that meant don't go use Azure Functions, because oh boy, I'll get in trouble if people start saying that. I think that what is absolutely happening and what we're seeing is that these PaaS layers are refactoring themselves, and even Azure Functions. I mean, you can take the Azure Functions open source runtime and have the functions programming experience on top of an AKS cluster. I think that people are absolutely seeing like, hey, why should I invest in Azure Functions if I can't run it at the edge? Why should I invest in Azure Functions if I can't run it on AWS? Why should I invest? So that's the more interesting question that I feel like is actually in some ways your subtext. And I think what we would say is, well, we actually understand that, and we want you to be able to go to all those places. We want you to have the same programming experience. If it makes sense to do functions as a service, it makes sense for us to enable you to deliver that wherever you need that code to run. And I think what I was trying to really say there was that's the future of PaaS, is a future where platform choice is more about what makes sense for your code rather than, oh, we're going to be an Azure Functions customer, or we're going to be an AKS customer, or we're going to be a container apps customer. I think that the future is one where you get to, where that doesn't feel like such a big choice, right? Hopefully we can get to that place where like you're like, oh yeah, today I'll use Azure Functions for this because I'm doing event handling. Tomorrow I'll use a vanilla container for this because I want complete control and to use 30 gigabytes of memory or whatever it is.
Makes sense.
Yeah. Azure Functions is very much not dead, just to be clear.
but
That's
again, it's
very
like,
true. I think
yeah.
when we talk to people about automation in the cloud, we can use it to hook on to so many legacy services. And I don't tend to think of AKS or functions. We see it a lot. I'll use Azure Static Web Apps as an example, or if you have a legacy system that you need to automate something with, functions are a great way to do it.
Yeah.
So I think, yeah, they're definitely not dead. The Azure Functions team is still alive. So is the Logic App team, right? We love low code, no code. But yeah,
it needs to be able to call into Kubernetes services, right? It needs to be able to call into services in AKS in a way that's simply too hard today, right? And I think that's what I really wanted to sketch as the future direction, where Logic Apps can call directly into some service that you've built on top of a Kubernetes deployment, and that they're running in the same place. And that also, when your Logic Apps gets too complicated and you want to actually go from low code to some code, you could hit the eject button and you get a bunch of containers that you can start writing code in, instead of right now where you're like,
yeah, I love that idea. We need that from ACA to AKS as well. So if you want to give some feedback to the team.
yeah, no, and that's in plan. That is definitely something that's in plan.
I think of these like things like it's abstraction layers, right? It's the ever extraction of something. And if you are developing a simple application and you don't want to think about everything, like obviously Azure Function will give you a lot of those things. But if you have a more complex organization that might have, certain governmental things that they need to think about, or some restrictions, or even just creating, your own platform on Kubernetes, it just makes sense that you can, for the like a product team or something, that they can have the option of doing serverless in one of many ways. And for them, it's more or less the same experience, but you can have like that control. Like if you are working on the lower abstraction, so to speak, it just makes sense that like it doesn't fit all. You start talking to some developers about AKS and how complicated it can get. Like they just see like this doesn't make sense for us. But if it doesn't, then you're obviously at the wrong abstraction layer, right? For me, as a cloud engineer, creator of platforms, Kubernetes makes so much more sense because I can do all these things.
Yeah. Well, and I think it's not even at the individual developer. I think it's sometimes at the individual project level.
Yeah.
Some projects make sense. Some projects you just want to get done and it doesn't matter. And you just want to spit a little bit of JavaScript and be done with it.
Yeah. It's the ever returning, it depends, that I keep on saying. Everyone's laughing at, but it actually does. It depends.
Yeah, for sure.
Yeah.
Cool.
Right. I think we're out of time now. We've gone over a bit, which is good. So thank you very much, Brendan, for taking the time out of your day to come and talk to us all about cloud native in Azure. It's been amazing.
Absolutely. Thank you so much. And, everybody knows where to find me. So look forward to talking to you in the future. So Thanks for hosting.
Thank you,
Thanks,
Brendan.
everyone.
Appreciate it.
Thanks. Bye.
Thanks,
Bye.